Alright, we move on to the next section of this topic. Okay, before we start off with that, let's look at this video. Okay, you may close your eyes, you just have to listen to that, and then you guess when is this ambulance arrive and approach you and then leave. Okay, you can just close your eye while I play this. So guess the point where it approach and leave. Okay. Alright, so if you cannot successfully guess when is the time when it passes through, okay, then you can play it one more time. Okay, so what is the thing that I want you to notice here is that you actually have a sense that help you, as in you can hear and identify the changes in this sound, especially its frequency. That's what we're going to talk about it today. So our ear actually can detect the changes in the frequency, as in when it changed from a high frequency to a low frequency, or we say from a high pitch to a low pitch. Okay, so keep that in mind first. If you cannot guess where is it, then you play one more time. Yeah. So now we go back to the slide. Alright, so that's the Doppler effect that we are going to talk about it today. So on top of this picture, I already pre-drawn some points there that I'm going to explain in a while. So this is the ambulance, like we see just now, but just that this is like one person having on the other side, which is left hand side, where the ambulance move away from it, and the other one on the right hand side is where the ambulance is approaching it. Okay, then you see those circle there. Those circle actually represent the wave fronts. Okay, so I have wave fronts. I have wave fronts 1, 2, 3, 4, 5. Okay, so by right, if the ambulance is not moving, then the wave fronts, they will not shift in such a way. So you can see that here is like very spaced out, and here is like very cramped. Okay, by right, if the ambulance is not moving, then it will be just equally spaced like what I had drawn here. So this is the initial or supposed to be spacing of the wave fronts 1, 2, 3, 4, 5 on the left hand side, and 1, 2, 3, 4, 5 on the right hand side. So the ambulance somewhere here not moving, then you get those. Okay, so if the ambulance is speeding, then you can see that those wave fronts is deviated from the position where they are supposed to be. They move forward together with the ambulance, whereas those behind here, they haven't arrived at the point they are supposed to arrive. So this is the wavefront 5, and this is where it's supposed to be at this moment. So because the ambulance has moved away, so it will take some longer time for it to arrive where it's supposed to be. Therefore, you can see that they are getting further and further away from the position that they are supposed to be. So based on the this distance between wave fronts, which we call the wavelength, so we can see that wave fronts or wavelength actually decreases as it approach, which is on this side here. Okay, hold on, let me bring out the pointer. Okay, so which on this side here, the wave fronts actually decrease, means the wavelength decrease, and frequency increases. And on the other side here, where wave fronts, distance between wave fronts increases, where wavelength increases, therefore frequency decreases. So therefore what you detect just now, or what you listen just now, is that when it comes towards you, or when it comes towards the recorder of the video, it actually has increasing frequency, higher pitch, and when it's leave or move away, it's actually having a lower frequency. All right, so the equation that governs the calculation is basically this one. It looks very complicated. Anyway, it's given inside the list of equations, so it looks very complicated. So but after I explain, you should be able to understand quite easily. So let's look at the FO here. FO here, you can write down here, stand for observed frequency. Observed frequency means the one that the observer listen or hear. Higher frequency just now, right? As it approaches, this is the observed frequency, supposed to be higher. And then we have the Fs here. This is the source frequency. Source frequency means the sound frequency coming from the ambulance originally. Okay, we call it the original frequency or the source frequency lah. Okay, the initial one. Then we have the V here. So this Vs first. Let's talk about the Vs first. Vs basically is like the S just now here. This Vs, the S here also stand for the source, the speed of the source. So in this case, it's the speed of the ambulance, the speed that the ambulance is moving. Okay, and then the other V here, this V is basically the speed of the sound wave. Okay, speed of the sound wave, which is usually about 330 or 340 lah. So this one is the speed of the sound wave, 330 or 340. Okay, then on the other side, we actually have the same thing. The only difference here is the plus sign and the minus sign. So which is sometimes very confusing because you don't know where to plus and where to minus, and most of the time you will just try to memorize that. So my suggestion is you don't need to. Okay, we can use our sense just now, the ability to sense the changes now, to figure out whether it's minus or plus. Okay, so one more time. When the ambulance approach, you are supposed to listen or hear a frequency that's higher. So let's look at the maths here. If your FO is going to be larger than the FS, so what would you have in this fractions here? Think about that. So if your FO is going to bigger than the F1, what is your ratio or the fraction here? Is it going to be smaller than 1 or bigger than the V? Okay, more than 1V or less than 1V? Okay, more than 1 or less than 1. So obviously our answer is less than 1. So to get less than 1, the denominator here, what you can put is actually the minus. So minus here becomes below here, it become a smaller value, and therefore if you have V divided by a smaller value of itself, then of course you get a value that is smaller than 1. Okay, no, sorry, larger than 1. Alright, so that's why you put a minus there. So denominator become smaller, then the whole ratio or fraction here become bigger. Okay, so on the other side here, the same thing here. If you want the F naught, because it's moving away, right? So it become smaller wavelength. Smaller frequency. So smaller frequency, how to make that in terms of mathematics is this fraction here must be now smaller. Must be now smaller. So how to make it smaller? Of course, you have to make sure the denominator is bigger. Okay, therefore it's a plus sign. Okay, so if you still cannot understand, you replay what I say, you should get some idea. Okay, so later when we do question also, we will practice that. So now let's go to the definition of this Doppler effect. You need to describe in words also. It's the change in the observed frequency, that's the FO, when a source of wave, that's the ambulance, moves relative to a stationary observer. So we only deal with stationary observer in A-level case. Of course, the Doppler effect also apply when the observer is not stationary, but we just deal with stationary observer. Yeah. So if the source move relatively, just like the ambulance just now, I said it's supposed to be stationary, but it move. So once it start to move, then there will be a change in the frequency. It's not its original frequency as in Fs anymore. Okay, it could be larger or smaller, depends on the situation. All right, so we move to one example. Before that, the same thing also can happen to light, but we are not going to apply the equation for light because that one is slightly more complicated. So Doppler shift or Doppler effect could also apply to light. Okay, because we know that the galaxies and the stars actually they are moving constantly in the universe. So therefore, through observations or through the observatory, we can actually see sometimes the color that they are supposed to show us, sometimes is shifted. Okay, sometimes it's shifted. So the one that is moving away from the earth is, it will experience this color shift called the red shift. Okay, that's why this picture here is indicating you the red color. Not that is the whole thing become red color, it's the spectrum has shifted to the red color wavelength. Okay, let's say by right it's supposed to be this purple color, so it shifted to the blue, then the green shifted to the yellow, and so on. So they shift towards the longer wavelength. And then for those galaxies or stars that is moving towards Earth at that point when we observe it, then it will shift to the blue color. Okay, shift to the blue color, because blue color is smaller wavelength, and smaller wavelength means higher frequency, so therefore it has a blue shift. Okay, blue shift again is not the whole thing become blue color, it's just that their color spectrum will now shift to the lower wavelength from what they are supposed to be. Okay, so no equation for this. There is, but you don't need to know. Okay, now let's look at one example here. A source of sound of 1000 hertz. So basically this is the original frequency or the source frequency. You have to label them correctly. Yeah? Moves away from a stationary observer at a speed of 30. So this is the speed of the source. And the speed of sound is this. So this is the V of the sound. What is the frequency of the sound heard by the observer? So they're asking us for the observed frequency. Okay, observed frequency. So the other thing is we need to know move away. So now we have two choice. FO equals to V divided by V plus or minus Vs times Fs, right? So back to the move away now. So move away, our sense tells us that it is going to have a lower frequency. Lower frequency. Okay, lower frequency means that this fraction here will now have to become smaller. Okay, will now have to become smaller than 1. Okay, how to become smaller than 1? Of course, you make sure the denominator here become larger. And how to make it larger? We plus it. Okay, we plus it, then it become larger, smaller than 1. Okay, it becomes smaller than 1. So let's see. So we have the 330 and 330 plus 30. Okay, so bigger than 330, therefore your observed frequency would definitely be smaller than 1000. Okay, so you can try to calculate that. So next one, we'll make it an assignment question. You try that out. Okay, this one you have to do two-way calculation so that you can find the overall change. Okay, so this is your assignment question. Okay.